So welcome to the talk on JUnit 5, as I like to say. For the anti-TDDers, I like to save the test for last. So we have the last show of the conference here. All right, first up, my name is Sam Brannen, a little bit about myself. So I'm a Spring and Java consultant at a company called Swiftmind. I founded in Switzerland several years back. I'm a trainer, coach, conference speaker, basically but at heart a hardcore developer. Been developing Java for over 20 years, core committer for the core Spring framework since 2007 when I took over the whole testing support. Wrote everything with Annotations, JUnit 4, TestEngines, etc. Been maintaining that ever since, and that kind of got me into the JUnit team. So I've been a core committer for JUnit 5 since October 2015. My company, Swiftmind, experts in Spring and Enterprise Java, also JUnit and stuff like that. So software architecture, code reviews. If you need assistance like that, you can contact us and we'll help you out. The agenda for today, so first up we want to talk about what JUnit 5 is in general, and then we want to talk about JUnit Jupyter, then talk very shortly about migrating from JUnit 4 if you want to JUnit Jupyter. We'll cover some of the new features in JUnit 5 or since JUnit 5 was released a year ago. The roadmap, of course, Spring Conference, got to talk about Spring and JUnit as well. And then if we have some time, some demos, more demos, and some Q&A. So first up, show of hands, who writes tests? Yay, everybody, cool, all right. Who uses a framework called JUnit? Yes, JUnit 3, anyone? I know some guys said he just ported everything to JUnit 4, so maybe he was the last one. Anyone who's on JUnit 4? Everyone else, yeah? 4.12, latest and greatest? Not so many people, okay. Anyone use TestEngines? 3 or 4, Spock, yeah, a few more, okay. So we got a little variety here. All right, who's actually on JUnit 5 already? Oh, more people than on Spock maybe. All right, cool. Okay, so what is JUnit 5? I like to say, if you know the matrix, there is no spoon, right? There is no JUnit 5, so you can't just upgrade the version from JUnit 4 and say now 5 and have everything work. We've made a lot of changes, which I'll talk briefly about. But basically, so JUnit 5 started with JUnit Lambda as a crowdfunding campaign initiated by 2 of the committers for JUnit 4, joined by some other people, including yours truly. Back in 2015, raised some money. Some of the companies donated developer time, and Pivotal was the largest supporter of the crowdfunding campaign there. In terms of the architecture, well, we don't have just this one jar anymore like JUnit 4 had. Now we have a whole bunch of jars. We have a whole couple of different projects. The big red section is the new JUnit platform. That's the core. And that's what the IDEs and build tools actually interact with. And then what you interact with is a particular testing framework. So you'd write code on top. In the green, we have JUnit Jupyter. That's the new stuff. JUnit 4, JUnit 3, that'd be the old stuff. We call that vintage instead of legacy, just because it's a nicer term. And then third party, so other people can also implement their own testing frameworks that run on this new JUnit platform. So JUnit 5 itself is actually the sum of 3 parts. It's the platform plus Jupyter plus Vintage. So the platform is basically a new foundation for launching any kind of testing framework on the JVM. Doesn't have to be written in Java per se. There's also a launcher API for launching the whole thing, configuring it, selecting what you want to run, various test engines. That's kind of like somewhat analogous to what a runner was in JUnit 4. There's also a console launcher to run this all from the console. JUnit Jupyter is probably what you mean if you say I'm writing tests in JUnit 5, right? So it's the new programming and extension model that comes with JUnit 5, and it has its own test engine. JUnit Vintage has its own test engine, and that's basically just an adapter for running JUnit 3 and JUnit 4 based tests on this new JUnit platform. So the first section is revolutionary. That never really existed before. Everything was all tightly coupled back in JUnit 4, but this new platform is actually decoupled from all of the testing frameworks. So the new JUnit Jupyter one runs on the platform just like any other testing framework would. It doesn't have any kind of special support. The next one is evolutionary, right? So JUnit 4 existed. You could write tests. JUnit 5, JUnit Jupyter, it now exists. You can also write tests, but we've improved on stuff. And JUnit Vintage is necessary to allow people to keep running their old tests alongside new tests, but on this new platform. So that's necessary. So in a nutshell, JUnit 5 is a complete rewrite of JUnit from scratch, improving on what JUnit 4 had to offer, learning from some of the mistakes with extensibility in mind. So it's modular, extensible, and modern all at the same time, based on Java 8 and above. And it's forward and backward compatible, which was very important for us in the design. So this platform supports any kind of engine, which means you can run JUnit 3.8, JUnit 4, JUnit Jupyter, Spock, all kinds of tests like that within the platform. And you can also support, it also supports any other kind of test engines imaginable, right? You could come with any on your own. So I know someone was just talking about coming with one for JMH, for example. So concrete examples, third-party test engines, there's already some out there people have implemented, Spec, C-Spec, Cucumber, JQuick, stuff like that. So if you want to check those out and see what there are, what's available, you can go to the third-party extensions page on the JUnit 5 wiki. In terms of Java versions, everybody likes a little geek poetry, right? So I don't know if you were around or noticed the streams last year with Works Fine on JDK 9 when JDK 9 was released. So I posted this a while back about JUnit 5 support and on different versions of JDK. So works great on JDK 8. That's actually the baseline. That's what's required. Works fine on JDK 9. We've always had automatic module names baked in, and we added support for scanning the module path for your tests in JUnit 5.1. And works again on JDK 10 and works like heaven on JDK 11. Got to find something that rhymes, right? So we've been building and testing against those for a while, and now we can even put an X over the early access thing there, right? Because we just got GA release for JDK 11. So in terms of IDEs and build tools, that's come a long way over the past couple of years, since 2015. IntelliJ has supported it first since 2016.2, Eclipse since Oxygen 4.7.1a. NetBeans coming up in NetBeans 10. Gradle, so we had our own plugin originally, you might see that in some tutorials and stuff, but there's official support in Gradle's test task with the use JUnit platform configuration since Gradle 4.6. Maven, there's official support in there since Surefire 2.22.0, and they're improving that as we speak. And Ant, surprisingly, they have their own support as well, and they actually beat the Maven Surefire team getting it, and so we applaud them for that. All right, for examples for that, I'm not going to show you that right now, but you can check out the user guide and some various sample applications that we have to see what you need to configure to get that up and running. In terms of versions, so it's just over a year now, right, since September 10th, 2017, since the 5.0 GA, and we've had 5.1, 2, and 3, and most recently a 5.3.1, so that's the latest and greatest. That's what you should be on. Don't go for 5.3, it had a few bugs in it, unfortunately. But basically, you see we have about a 4-month cadence for the releases, and we're hoping to get 5.4 out before the end of the year. We'll see how that goes. So what is JUnit Jupyter? Well, what is Jupyter? Anyone? Which, numerically speaking, it's the 5th planet from the sun, right? Oh, and it also starts with JU, so what a coincidence. So that's why we picked it. So we didn't call it JUnit 5 because the whole thing is JUnit 5, right? It's an umbrella. And it would be really stupid if we called it JUnit 5 and then we released version 6 and said, this is JUnit 5 version 6, right? So we figured a code name would work out better in the long term. So in a nutshell, what is Jupyter? Again, it's the new programming model and extension model in the JUnit 5 umbrella. In terms of the program model, right, that's how you write your tests, annotations you use, assertions, assumptions, and the types and styles of tests you can write. The extension model, that's how you and third parties can extend the framework and add additional functionality. So frameworks like Spring, Mockito, Selenium, etc., or maybe you have some custom in-house needs where you need to extend the framework. So the program model in general is more powerful than what we had in JUnit 4. So basically, what can you do with JUnit Jupyter that you couldn't do with JUnit 4? Quite a bit. So we're a bit more lenient in terms of visibility. Everything doesn't have to be public. Just don't make it private. Otherwise, we'll find it for you. Custom display names, so not just technical. There's an @display name annotation. It can contain spaces, special characters, and even emoji, which is a super hit, right? A display name generator is coming up in 5.4, so you can have kind of custom display names generated. Like if you use like underscore pattern, then all the underscores will be converted to spaces and stuff like that. So you can basically have nicer display names without having to use this annotation. Tagging, so JUnit 4 had experimental category support, you might have seen that. We have an @tag annotation that replaces that, more powerful, and we also introduced a tag expression language for selecting these with like and, or, and not, and grouping and stuff like that, and that came out in 5.1. So anytime I have this red exclamation mark, it signals that it's something that was introduced since the 5.0 GA release. So if you saw my talk last year, these are the things that are new since then. So let's look at an example test here. We have a calculator test, very common. Subject unit test is calculator, just instantiate a new one. No need to do that in the before method. We're using the same one or a new one for each test method in this case. One thing you might notice to start off with, right, the public keyword is gone. So we have just class calculator test and just void add. You don't have to type public if you don't want to. The test annotation looks pretty similar. One thing to note, it does not have the timeout and expected attributes like it had in JUnit 4. We have different ways to do that in JUnit Jupyter. And another thing you'll notice is that we have these custom display names. So you could just leave them off, and then the class would be called calculator test, and the method would be called add. But we see here with display name, we have this add symbol here, the plus sign, so you can have emoji and custom things in there. Another thing to note is that in the assertion, two things. First thing is that the failure message comes at the end now, right? Because that's optional. So we switched that from JUnit 4 to JUnit 5. And another thing is that this can be Lambda expressions or method references. So if your tests don't fail, if they pass, then there's no reason to concatenate strings and build up a failure message, right? So we just do that lazily if the failure actually occurs. So here we have that Lambda expression. Next up, timeouts. So again, that's not in the test annotation anymore or with a rule. But what you can do is basically supply a Lambda expression or a method reference and just assert a timeout for a very specific block of code. So the first one we see commented out is asserting a timeout of duration, milliseconds, so 1 second, 1,000 milliseconds for this invocation of the Fibonacci method, right? So if it takes too long, then we get an exception or an assertion failed exception. Otherwise, it would pass. So the assert timeout is going to run it in the same thread and not end it preemptively. So it might run forever. So if you want to kill it off, if it takes too long, you could do assert timeout preemptively. Just be aware that it is going to run in a separate thread. So if you're using some framework, for example, maybe Spring with transactional support, where Spring's transactional support runs or is tied to the bound to the thread local, then that would not work. So you just need to be aware of the difference between a normal timeout and a preemptive timeout. So a demo, just want to show you this stuff actually works. I would love to do live coding, but we're a bit pressed for time, so we won't be doing that. But here's this calculator test. So we got the display name and everything, and if I just run that, should run not too surprisingly, right? Everything passed, and just to show you, we actually see the emoji and stuff showing up in there, so you can have nicer names and stuff like that, and double clicking should go straight to it even though you have emoji stuff in there. So it's going to look it up based on the technical name, not based on the emojis and stuff in your display name. All right. So even more power in Expressiveness. So we have support for meta annotations. So any annotation in JUnit 5 can be used as a meta annotation. So you can create your own custom composed annotations, like you're maybe familiar with Spring, right? So you can combine annotations of JUnit or with JUnit and Spring or any other framework that also supports looking up their own annotations as meta annotations. Another feature we have is what's known as conditional test execution. So you can decide when things should run, like on a CI server on Windows and stuff like that. Dependency injection for both your constructors and your methods allows for new things. So you can have like, final immutable fields for your test instances and stuff like that. Lambda expressions and method references in various places since we're based on Java 8. Another thing with Java 8 is interface default methods. So that brings in something, a new player to the game, something that I like to call testing traits. So you can basically have multiple inheritance in your tests, and you can have some kind of testing traits for various contracts you want to test, and you implement part of it as default methods and interfaces, and then you just implement the interfaces that you want to test together, potentially overriding some abstract methods and stuff like that. Nested test classes, something new in JUnit Jupyter. There's some custom runners that did it with JUnit 4, but you have a different way to structure your tests and have shared configuration and shared state and nested in a nice display in the IDE and the reports, and we'll have a look at that. We also have repeated tests, parameterized tests, and test factories for dynamic tests. And you can also control the test instance lifecycle, which you couldn't do with JUnit 4. So with JUnit 4, you always got a new instance of your test class for every single test method. And that's the default in JUnit Jupyter as well, but you can switch that to test instance per class, and then it acts like TestEngines does. So JUnit is going to cache the instance and allow you to have shared state across your tests. And that'll also play in nicely when we implement scenario tests in a later version of the framework. So tagging and custom annotations. Again, tag, very simple, just use that tag and add a string. You can put on a test interface class or method, something like this, tag fast, and that's my fast test. But you can also create custom tags, so you want to avoid having typos, right? So you can declare that as a meta annotation. You have your own custom @fast annotation here, and you've annotated with that tag fast, and then you can just say @fast, right? So it allows you to avoid issues with typos or changing the name of the tag. But you can go one step further, right? So you can have composed tags, composed annotations. You can declare tag as a meta annotation with other annotations from JUnit or potentially even from Spring. So in this example, we see two annotations from JUnit. We see add tag fast and add test, and we're just saying this is a fast test, and then from then on we can say add fast test. But maybe in Spring you might want to do something like database test, and you might want to have it tagged with add tag database and add test, and maybe add transactional from Spring, so you can really combine a bunch of stuff. So repeated test, parameterized test, and test factories, more power than what we had in JUnit 4. So JUnit 4 has parameterized, but this is slightly different and more powerful. So repeated, if you want to run something multiple times, very simple, just say how many times you want it to run. Maybe you have something you want to check for item potency or make sure that it's not flaky. You can also access the current repetition and total repetitions to make a custom display name if you wanted to. This is an example translating the default English display name into German. And parameterized tests. So you just annotate a method with at parameterized test instead of at test, specify the source of the arguments, obviously overriding display name, and we have various different types of sources. So value source for things like primitives, enums, method source for factories, CSV, so coming from some hard-coded CSV entries or coming from an actual file in the class path. And then argument source and argument provider if you want to implement your own kind of source. In terms of conversion, we have support conversion and aggregation from these sources. So implicit conversion for primitive types and their wrappers, of course, support for enum constants, also support for things like file, URL, currency, locale, stuff like that. And that's one of the more recent features. Also support for Java time types, so locally time, stuff like that. Also factory constructors or static factory methods, so for string to object conversion, we support that as well. Then there's also explicit conversion support, so if those other things don't meet your needs, you can say add convert with and provide your own custom converter. We also have support for basically supplying patterns for Java times. And in JUnit 5.2, we introduced support for what we call aggregation. So it's basically a style of mapping. So you have access to a nice API for accessing all the arguments coming from one of those sources for a particular invocation, and also the arguments aggregator. So that's basically like saying, take this one row from the CSV file and map it onto a person object, and then actually pass the person object into the test method. Here's an example, parameterized test with @value source with strings. So each of these is a palindrome. They're passed in as the candidate, and then we're asserting true, testing our is palindrome static utility function here, and this should all pass. If you didn't want to do it statically like this, you could pull it out somewhere dynamically. Here we have a palindrome's static factory method in the exact same test class here, and we're returning a stream of these things. You could also return a stream of arguments, different types if you want, but this is just a single string of one type of argument. So here we have the little note here at the top with the /palindromes commented out. So you can specify the name of the method if you want. Locally, you can also specify a fully qualified method name for a static factory method in another class. And if you leave it off, JUnit is just going to go use a convention and look for a method with the same name in the same class. So that's why this works here. So palindrome is the name of the test method, taking a candidate, and palindrome is also the name of the factory method that's generating these candidates. So dynamic tests, something quite different. You might not have seen that or even thought about the need for it. So basically with JUnit Jupyter, you can generate tests on the fly with Lambda expressions. Totally dynamic. It could even be non-deterministic if you wanted to. So you can create any kind of stream. You just have to return either a dynamic test, a stream of dynamic tests, or dynamic containers. So you can have nested dynamic structures if you want. And each of these ends up being a little Lambda expression. So we see this dynamic test down there at the bottom, and that's generating a dynamic test on the fly with a given test name, so test plus n, and then the Lambda expression we're pointing to what we actually want to invoke for that. So we can do things quite dynamically. And I'll just show you some of these running so you have an idea what this looks like. So repeated test, I'll just do the repetitions of this one. I just want to show you the structure. So you see you have the repeated test, the class, the repeated test method is the container, and then you have the individual invocations underneath that. And if you double click on one of those, it goes straight to the method. And you should be able to actually rerun a single one and not run the rest. So let's see if that worked. Yep, that worked. So that's in one of the more recent versions since 5.0 GA. In terms of parameterized tests, we have that example I had before with palindromes. It's taking a method source. By default, it's going to find this palindromes method here and run it with those. So if we just run this test here, it should look similar. Parameterized test is the class. The container is the parameterized method, and these are the actual invocations underneath that. So we see that we have this default invocation index, and the actual parameter was passed in. And you can customize what that looks like, that display. Dynamic tests, here we have a couple examples. I'll run these. So the first one's making a stream of ints, the second one's making a stream of strings. And if we look at those, we should be able to expand all, and we see the individual invocations, right, for each of those. So we have more power and then nice displays in the IDE. Okay. Moving right along. Okay, new feature in 5.3 is parallel test execution built into the framework itself. So to configure that, you just need to set a flag to turn it on. It's turned off by default. You can do that in the JUnit platform properties file in the class path, normally in source test resources, via the launcher API, maybe via your build tool, or via JVM system property. And you can optionally configure the strategy. By default, it's going to be dynamic based on the number of cores and CPUs you have. You could set it to fixed or some kind of custom implementation. You can also change execution mode, so once you've turned it off, you might want to disable it for a given test. You can just set execution to the same thread, and then it won't be running parallel. You can also control synchronization, so if you want everything running in parallel, but you need to control some things that shouldn't run in parallel, you can define resource locks. Those are just strings, so you name them something unique. So maybe my resource or database or something like that. That's going to default to a read-write lock, but you could also switch it to a read lock if you wanted to. So just as a quick example for that, parameterized Fibonacci test, so we can pull that one out. So I got its false right now, not turned on, and I got this test here. Should take a little while to run. It's going to compute a few Fibonacci's that take a little longer. And let's see how long they take. So I have a nice little logging extension here that's also logging which methods are running. Right? So we see it all finished now, and how long did it take? We look at this number up here, 8.9 seconds. Okay, I don't have a multi-core computer. Mine's old, but it should still be able to get it to go a little faster. So let's run it again, switch it to true. 8.9, we see one thing different here. It's not all on the main thread now, so we see some worker threads, right? So the fork join pool is how this is implemented in the background, and now it ran in 6 seconds. So you can imagine if you have more cores, you're gonna get faster runs. So that's a nice, much awaited feature that came out in 5.3, so just within the past month. Okay, so we focus on extensibility as well. New extension model, just marker interface, a different package. Basically, it has all the interfaces there. You can implement as many as you want, which you couldn't do in JUnit 4. Register them with extend with. You can register one or more at the same time on a class interface or method, or use that as a meta annotation. And you can also register extensions via fields. That's kind of like @rule in JUnit 4, and that's new since 5.1. So there's a number of extension APIs. I'll let you look them up on your own. But basically, we have support for various lifecycle callbacks, exception handling, these conditions, so stuff for dependency injection, so new test instance factory since 5.3, post-processing, that's what Spring does for dependency injection, parameter resolvers, and we also have this test template invocation context provider, and that's what's used to implement things like repeated tests and parameterized tests. So this disabled annotation, what's so important about it? It's kind of like that add-ignore from JUnit 4, but this is where we say the extension model meets the program model. So we've implemented this as a disabled condition, eating our own dog food, and this is basically a game changer because you can also do this as well. It's not limited to a feature within the framework. You can also deactivate various conditions if you want to see if things are still broken, or maybe just to turn them off for a minute. So we have built-in conditions. We had disabled since 5.0, and since 5.1 we introduced a bunch more at enabled if, at disabled if for executing scripts like Groovy. And then we have various things for testing, am I on JDK 8, JDK 9, am I on a Mac or Windows, is a very system property and variable set or not set, so you can use these things, these built-in conditions to determine where your tests run. So migrating to JUnit 4, or from JUnit 4 to JUnit 5, do you have to? No, you don't really have to. You can if you want to. You can keep running, or you can start running JUnit 4 tests on the platform using this vintage test engine, right, just like an adapter. And you can also run those tests alongside your Jupyter tests or other tests on the platform in the same project, not a problem at all. So you can gradually migrate your existing tests to JUnit Jupyter if you want to, but you don't have to, right? You can just keep them there if you want. If you don't have any need to upgrade, then don't. Just write your new tests in JUnit Jupyter. So in terms of some tips, so things move to the new package. Make sure you're not using the test annotation from org.JUnit, but using it from the JUnit Jupyter API. Add-ignore is disabled. Other annotations got new names. So before and after, before all, after all, etc. Assertions and assumptions are in new classes. And again, the failure message comes last with the assertions and the assumptions. So we have support for migrating rules, enable rule migration support. Allows you to use some of the rule types you had from JUnit 4. So for example, if you're using temporary folder or error collector or expected exceptions, you can continue to use those types of rules if you're using this migration support. And new since 5.0. Some of the features I've already mentioned. JUnit Maven Bomb, simpler to manage your dependencies. For example, Spring Boot does that. Parallel test execution. We can also capture output to system out, system error. Tag expression saw that. Improved Kotlin support. Number of enhancements, reg extension, test instance factory, etc. So on the horizon, what's up and coming? In JUnit 4, we've already started work. So we're going to have improved JUnit 4 migration support, support for JUnit 4 assumption, exception types, and ignore annotation. A new display name generator, a new test watcher extension API to see the results of tests and maybe log stuff based on that. Ordering for test methods and extensions registered via fields. And support for test suites, we're hoping to get that in as well. Parameterized test classes, so we have parameterized test methods. We'd also like to be able to do that at the class level, so to implement stuff like tests or TTKs. Scenario tests, something similar to what you can do in TestNG, we'd like to support that. Test kit, so basically a way to test your own extensions. So basically a testing framework for the testing framework, but also for third parties to use. And we need a new reporting format. So we saw we have these custom display names. We have more features in JUnit Jupyter than there were in JUnit 4. And the old JUnit 4 and JUnit 3 XML reporting format, from Ant and everything, doesn't cover everything that we need. So backlog. There's some things we're looking for in the future to implement. Executing stuff in user-defined thread, custom class loaders, global preemptive timeouts, so not just on a code block basis, programmatic extension management, and other things. So there's still a lot to do. We've come a long way, but we got a lot to do. And closing up here, Spring Conference, let's talk quickly about Spring and JUnit Jupyter. So Spring support for JUnit Jupyter, been fully integrated since Spring Framework 5.0. Supports all of the core integration testing features you've come to know and love over the years, but also adds some support for new things that weren't possible with JUnit 4 or TestNG. So this constructed method injection, you can do that with add autowire, add qualifier, and add value from Spring. Can be pretty nice. Conditional test execution with spell expressions. So JUnit Jupyter supports other kinds of scripting languages like Groovy, stuff like that, but you can use spell expressions with Spring. And we have some simplified configuration annotations. It does, however, also work with 4.3. I wrote the original 4.3. We're not going to backport it, but it is available in my public GitHub repository, and there's some notes there for how you can use Jetpack or something if you want to use that. So this is an option if you can't, for some reason, upgrade to 5.0. But of course, you should upgrade to 5.1, right? Spring Framework 5.1. So how to configure JUnit Jupyter Spring. There's the Spring extension instead of the Spring runner, and you just say add extend with Spring extension. Then some simplified annotations. Spring JUnit config combines add context configuration in this registration. Similarly for the web, we have some simplified usage that combines that with web app configuration, and then these enabled if and disabled if annotations from Spring that support spell expressions. So Spring Boot 2.1 in JUnit Jupyter, nice mix. Actually just works out of the box. So the Spring Boot test annotation, you can combine that with JUnit Jupyter support. It needs the add extend with Spring extension, but luckily in Spring Boot 2.1 that's baked in. So we see in this example here, I've commented out the registration of the Spring extension because that's done for you automatically by all of the new Spring Boot test annotations, which is quite nice. So now if you have JUnit Jupyter in the class path and set up and you say Spring Boot test, you're going to get Spring Boot running with JUnit Jupyter, and then you can just use the other features from Spring Boot test and from Spring. So here I've made a custom annotation, Spring Events Web Test, and then I can just use that, annotate my test class with that, get all those features baked in, write my test, custom display name if I want, and then here we see the use of add autowired for MockMve, so having that injected locally into the test method. Now, this could be a good practice or a worse practice. It depends on what you're doing. If you do this in every single method, then don't, right? Just inject it into a field or a constructor. But if you only need something in one particular place, one dependency out of the application context, then you could optionally have that injected directly into a test method or into a before each method, etc. So, getting involved. How can you help out? You can participate on GitHub, right? Reporting issues, suggesting new features, participating in discussions, design discussions, and stuff like that, or helping with reviews. You can also answer questions on Stack Overflow in our Gitter channel. But you can also support the team with donations via StudyHQ. So the team just announced this earlier this week. There's a website if you would like to participate or contribute or have your company contribute to JUnit's further development. So looks like we're out of time for more of those demos, just trust me, all the code works. It's all tested. I'll give you a link. You can check it all out. So in closing, yeah, a bunch of links are included here where you can find all the stuff. If you got questions and everything, Stack Overflow or Gitter. Demos used here in my account, my GitHub account, and also part of the documentation project from the team itself from JUnit 5. So thank you for coming. I'll step outside afterwards and maybe answer a few questions.